Yes, yes, the confusing step is actually very simple. We are comparing to equation. So yesterday we have covered what is transmission line equation. Why we get dv by dx equals to uh, this is this. Okay. Yeah, here. Why we get dv equals to dv by dx equals to minus z by side. Remember v equals to ir formula for AC signal for power line equations. We say impedance equals to R. Then we say dv by dx equals to IR, V equals to IR, right? So small part voltage in transmission line dx equals to minus z dash I. Here, remember IR formula, so you remember this. And the di by dx equals to, but both are not same. Resistance and impedance are not same. Right? Impedance means opposition, it includes capacitance, etc. And di by dx equals to for resistance, it is for di by dx I equals to v by r. 1 by r means here admittance. So we get minus y dash v. So this is simply two parameters in front. For increase in v, how we say, for series impedance connects voltage change to current. For voltage change to current, it connects. Here it is current change to voltage, it connects. Then the d square, if we differentiate on both sides for this equation, then we get d square v by dx square minus z dash di by dx. Then substituting di by dx equals to minus y, this value here in this equation. Uh, in this equation, then we get d square by dx square equals to z dash y dash v. So gamma square equals to z dash y dash v. Then therefore gamma equals to root over z dash y dash. Here you can see how this converted to gamma here. That's why we will have the explanation here. Before that, we will see why here we get gamma equals to root over z by. For impedance, if we follow the same process, we will get the root over z dash by y dash. Just remember like that. Then the confusing step is actually very simple. So, how the gamma equals to root over came. So if you look at this, actually for voltage traveling across the transmission line, this is the equation. V of x equals to V naught e power minus gamma x. Differentiate one side, dv by dx equals to this will come. Therefore, V equals to V naught e power minus therefore V naught e power minus gamma x equals to V. In place of this, we will substitute V. Then dv by dx equals to minus gamma V. Then d square by dx square equals to gamma square V. Then d square by dx equals to gamma square V. We got substitute in the before equation. D square by gamma square V will say substitute here. V get cancelled here. Gamma square equals to z dash y dash. So that's how the equation here for gamma. Uh, Actually, if we prolong the equation, we will get to something like okay, that's not important. We can substitute these values and for we can substitute these values for impedance. We can actually substitute the values alpha plus j beta. Why gamma equals to alpha plus j beta? Then we can ask. Then if we substitute in the v square v equals to v naught. Before that, we'll see the how what is open circuited and short circuited line. So open circuited line, short circuited line, reflection, standing waves, reflection coefficient, voltage standing wave ratio, impedance matching. First, what happens when a wave reaches the end? The incident wave is reaching the load from source to node. Uh, so ZL is ZL equals to Z naught, then reflection coefficient, why does mismatch comes? If ZL equals Z naught, there is no reflection. If ZL is not equals to Z naught, ZL equals Z0, there is no reflection. ZL is not equal to Z0 means load impedance is not equals to the characteristic impedance. Then there's a reflection. Why does mismatch cause reflection? Suppose the transmission line has Z0 equals to 50 ohms, but you connect ZL equals to 100 ohms. The traveling wave expects a 50 ohms formation but encounters a 100 ohms. Therefore, the wave cannot transfer all of its energy into the load. Some energy is reflected back. Reflection coefficient. Even the reflection coefficient to tell us how much of the wave is reflected. It is simply the reflection coefficient ZL minus Z0 by ZL plus Z0. ZL equals to load into Z0 characteristic impedance of the transmission line. In the transmission line, here the point is the reflection coefficient you will say this symbol is here. Reverse value is here. If you look at this, it looks like L, but it in reverse. Okay. Match line. Suppose ZL equals to Z0, then reflection coefficient is 0, no reflection. If ZL for a short circuit, ZL load impedance is 0 means you can look it as for a short circuit there is no resistance, current is infinite. So ZL equals 0, 0 minus Z0 by 0 plus Z0, then the reflection coefficient equals to minus 1, minus Z0 cancel, minus 1 will come. So there will be a 100% reflection with a 180 phase reflection. For an open circuit, transmission line open, then means there is an infinite resistance, air. So air is infinite resistance, so ZL is infinite. So infinite minus Z0 by Z0. Here he used just one method to calculate. Here what he done is, he taken the ZL minus Z0, ZL plus Z0. He divided by with ZL, then this value will become like 1 minus Z0 by ZL by 1 plus Z0 by ZL. When Z0 by ZL will substituting, it will come like Z0 by infinity. Uh, then 1 minus Z0 by infinity means 1 minus 0. 1 minus 0 by 1 plus 0 means plus 1 will come. So here 100% reflection with time without phase reversal. So matched means reflection coefficient 0, short circuit means minus 1, open circuit means plus 1. Why do we get standing waves? Now come the interesting part. Suppose the load is mismatching. If the load is mismatching with the positive impedance, incident wave, then reflected wave will come. So at the locations of the cables will add together. So at the location of the cable, the incident and reflected waves add together. So incident wave and reflected wave add together. Vi plus Vr. At other location, they cancel each other. At other location, it becomes Vi minus Vr. Uh, Therefore, the voltage current patterns doesn't simply travel forward. It forms a stationary standing wave. This forms here maximum means we call it continuous, minimum means we call it nodes, minimum voltage we call nodes. Why this is yes, load mismatch reflection standing wave VSWR. So what is VSWR? This is simply Vmax by Vmin. Vmax means this is Vmax, this is Vmin. So this is simply Vmax by Vmin voltage standing wave ratio. If we already understood what is the impedance mismatch, VSWR tells severe standing wave pattern. This tells the pattern. Why does this tell us about mismatch? Perfectly matched line ZL equals Z0, standing wave ratio is equal to 0. Then Vmax equals to Vmin, therefore VSWR equals to 1. Vmax by Vmin is value becomes 1. This is best possible value. Matched line, if it is this is for a mismatched line. Suppose the reflective wave is significant when Vmax is greater than Vmin. Therefore, VSWR is greater than 1. Vmax by Vmin is increased, right? Means it has a value greater than 1. The greater is mismatch. Connection with reflection coefficient. Here, we know what is reflection coefficient. This value is VR by VR. Reflection coefficient originally the value in terms of voltage of impedance and reflected wave means VR by VR. This is new to you. So incident wave amplitude, this is not V means not voltage, sorry, it is amplitude. Reflected wave amplitude at the location where the wave is at, V max equals to V plus VR. We already looked this here here only in the explanation it told like it told same location and the income waves add together here told means VI plus VR add together. It cancel together VI minus VR. Here we get input output, then we substituting. But if we divide it by VI, then the VR by VI will come. Then VR by VI means in terms of we'll get reflection coefficient in terms VSWR. This is important relationship. Three cases to remember: matched line, reflection coefficient equals 0. Therefore, VSWR equals to 1 plus 0 minus VSWR equals to 1 means matched line. Complete reflection, if you the this is for short and open circuits. If plus 1 minus 1 okay, got reflection coefficient for short and open circuits, if you get magnitude of those, then we'll get 1. If you solve it, we get infinite. This is for matched. Some mismatch, if there is a mismatch 0.5, then VSWR equals to 1 plus 0.5. It 3 is to 1 ratio it gives. This spells mismatch. The whole chain shadow equals Z0. So this is all you understand. This is means complete reflection. This means mismatch increasing. This means perfect match. Next one is transmission. Transmission line as a circuit element. Here you see line as a circuit element. The important idea the transmission line itself can behave like an impedance when you look into that from the source line. So imagine a transmission line connected to node. So this is input impedance. It has some input impedance, okay? So it has an input impedance, source of impedance Zin. Transmission line static impulse is Z0. Load impedance is ZL. So input impedance Zin equals the incident wave, reflected wave, all this depends on load or characteristic impedance, line length, frequency. The important formula is for a loss wave transmission line, Z equals to Z0 into ZL plus JZ0 by tan beta L. Z0, Z0 plus JL, ZL tan beta L. So just remember this, why this formula, of course, you ask, when calculating V equals to, uh, uh, if you simply don't bother this. So why it came? Z0 ZL plus Z0. So tan beta L, this is a derivation where in the formulas V equals to V naught e power minus j beta. This is simply for to substitute the Euler's formula in it, the Euler's formula. G power j beta in exponential terms is converted as cos beta plus j beta, j sin beta. For reflected wave, it is cos theta minus j e power minus e power minus j theta equal to cos theta minus j theta sin theta. Then because of this, in the derivations, we get this formula tan beta L. So simply remember this formula. Z naught equals ZL plus J, Z naught tan beta Z, Z naught plus J, ZL tan beta. So this is line length of the cable's line length beta. Beta is phase constant, phase of the signal. So don't try to memorize. The line changes what the source is. If Z not equal to 50 ohms and you connect some load at the end, if you change the cable length, the input impedance can change. So for some 10 meters cable, 1 Z in, 25 centimeters cable, the Z in changes. For 50 centimeters cable, another Z in. That's why transmitter can activate circuit element and match the impedance of source and load. The most important special case is if ZL equals to Z0, means no mismatch between impedance, then the equation converts into Zn equals to Z0. If we solve it, Z0, ZL place we put ZL, Z0. Uh, this place we put Z0. Both look same, we cancel out. Here ZL we put Z0. So we get Zn equals Z0. Let's say property terminated 50 ohms cable looks like 50 ohms from the source side. Short circuited line. Now load is 0. Now the load itself is 0. Put that in the formula. We put it that in this formula. ZL equals 0. ZL equals 0. These equation disappear. So Z naught equals to J Z naught tan beta L by Z naught cancel out. So J Z naught tan beta L will remain. J Z naught tan beta L here. The load itself is 0 ohms, but the source can see non-independent because of transmission line. Open circuit line. For an open circuit, ZL is infinite. The result becomes, if we solve this using the previous logic we used, here we put ZL by ZL, here Z0 by ZL. So these two values will be this ZL by ZL1, this ZL by ZL is 1. These two values becomes if we substitute infinite 1 by 0, these values become 0, then ZL by JZ, 1 by J, 1 by J tan beta will be there. This 1 by J tan beta, beta tan beta, so J tan beta will go upward. So it will become cot beta L minus J cot beta. This is straight goes upward minus J. So the final value Z1 equals to minus Z0 minus J Z0 tan cot beta L. Where you can see that the value is cot beta L for open circuit line. Why is this useful? Suppose to matching the impedance, source is 50, load is 100. How can we match the impedance? By simply the increasing the cable length. The load doesn't match source or transmission line. Instead of load changing the load, we increase the length of the transmission line. For example, okay. For example, look at this. Suppose we have casting impedance 50, ZL length is 100, um, ZL is not equals to Z0, so ZL equals to Z0. We want ZL equals to Z0. So the now basic idea we do is then we replace ZL has we replace transmission line with 50 ohms impedance. Means increasing the length means the impedance we see it as 50 ohms transmission line. Then ideally the load impedance will come with 50 because at the end we need 100 impedance load when then the reflection becomes matched reflection is 0. VLWR equals to 1. Power transfer is maximum. That's enough for the basic concept. One important matching method, a quarter wave transformer can be used to match different impedance or if you are confused here, like here ZL says 100 ohms, here it is says ZL equals to 50 ohms. If we said Zn equals to Zn equals to, yeah, it should say like Zn equals to 50 ohms. I think. It says Zn equals to 50 ohms. Like he explained, like you see, he explained like for a cable, increase the length of the cable to match the impedance. Source impedance is input impedance 50 ohm. We want 100 impedance, so we make the cable impedance 50. Then the load impedance will become 50. So impedance matching, Y matching. Suppose Z naught equals to 50 ohms, but the load is ZL. With the basic impedance matching, making the load equal to the characteristic impedance of transmission lines. Uh, so this load transmission lines makes the load of the um, impedance of transmission lines. If you want to make the impedance of the load 50 ohms, that's the impedance matching we talk. This is another concept. A quarter wave lambda fit transformer can be used to match impedance. The lossless quarter wave ZL equals the advanced cable ZL. So next so that's all for this all this. So we have also some skipped the time there are the derivation of this tan beta. Here look at this for Vmax V plus V for induced wave V plus V per minus J beta for reflected wave V minus V per minus J beta. As the current is we can say V by R wave V by Z V by this. Then by substituting these values ZL equals to E plus ZL equals to E by R, right? So by substituting V value here and then V by Y value here, then we will get this value ZL equals Z naught VB. Here reflection coefficient is this, and because of this we get the coefficient coefficient ZL by when it's Z naught by ZL plus Z naught. Now move a distance away. Now uh, we get this Zn by Vn. You say Vn equals to Z naught. We substitute here 1 plus we substitute this here. V minus V plus this V minus V plus V now it is a reflection coefficient. Then e power minus reflection coefficient e power J2 beta, e power J2 beta. This is already important for impedance equation. Solving this, we get reflection coefficient of the load. This is the load V minus by V plus reflection wave by induced wave. Then convert into this formula, then fraction wave equals to ZL minus Z1 by ZL plus Z1. And some algebraic expression becomes Zn equals to Z0 into reflection coefficient element ZL minus Z0 1 plus say 5